hello, Texas Linux Fest. Thank you all for coming out. I'm very happy to be back. This is Mesh Network Sidecars for NixOS services. Okay, let's get started. Okay, a little bit about me to start. I'm a software engineer interested in functional programming and distributed systems. And very recently, a Nix nerd. Well, maybe not that recently. I don't know. It's been about 2 years or so, but it still feels very recent. I always knew I'd be interested in Nix because I like functional programming, but it was one of those things that you just need to be distractingly interested. So I'm finally admitting and coming clean to myself that I really am a Nix nerd. And of course, I am a co-host of Linux Unplugged on Jupiter Broadcasting. You can find us rambling about all things Linux and open source, and of course, KExec every week. We like to think of ourselves as the world's largest Linux podcast. And then when I'm not doing all that, you can find me wandering around the woods of the Pacific Northwest. I'm a Seattleite with my dog Charlie. Okay, so if we're talking about mesh network services for NixOS, mesh network sidecars for NixOS services rather, we probably should define some terms. So first up, mesh networks, also known as overlay networks or peer-to-peer VPNs. You're probably familiar with them these days with things like Tailscale or NetBird or Nebula. You basically get one flat network for all of your devices, all of your services, and you can really contrast this with something like a traditional OpenVPN hub and spoke type VPN model where maybe you're just joining two subnets together, allowing remote employees to access a LAN somewhere. The idea here, right, is you run a VPN connection on every single device. They get their own unique name, they get their own IP address on this virtual flat single network. You know, you don't have to worry about, oh, well, do we have, IP collisions between site A and site B, because the only IP you end up caring about is the IP or the domain name on your private internal mesh network. It also really is nice because it lets you decouple things, you can move things around, and if all you care about is, the host name on your virtual network, then nothing changes if it has to be moved to another host after, you had a hardware failure. I've been playing with them for a little while. And they've been around for a little while as well. Tink goes all the way back to 1998. That's what I discovered first. And then there was a bit of a renaissance. I mean, there's been a lot of technology in this area, but I think we got interested again when Nebula came out in 2019, and that was also the same year that Tailscale got started. NetBird came along a little later. A lot of these kind of got kicked off, not Nebula, but Tailscale and NetBird, of course, once the Linux kernel got WireGuard, which we at Jupiter Broadcasting really just love. And it's not just used, for accessing your home lab while you're here at Texas Linux Fest. Nebula came out of Slack because they really like this idea of one flat mesh network that could span various VPCs or, data centers across the world, really. And a lot of these have technologies built in, like they've got modern style cloud firewall rules, so you can say like, oh, well, only hosts that have permissions to access, database hosts can actually talk to the database on its mesh network address. And it can really simplify things like access. Okay, so there's become something quite popular, a pattern to use with these mesh networks, and it's called the sidecar. Just kind of curious here in the room, any of you familiar with the sidecar pattern? It's used a lot in containers, Kubernetes. Yeah, okay, a good portion of the room. So on the screen here, we've got a Docker Compose setup, a YAML file here, running Vault Warden. And this comes from the Tailscale doc, so thank you, Tailscale. So the first part up there is just running the Vault Warden service. The key thing to note is it says network mode, and the network mode is accessing the Tailscale sidecar. And what's that? Well, it's another container running in the same Docker Compose setup that's just running Tailscale. You do have to kind of give it the right environment so it has permissions. You kind of got to give it some permanent state so it can store things. And, it needs some permissions to do its fancy networking stuff. So that's where you get stuff like netadmin or sysmodule down there at the bottom. But really the idea is instead of having you start with a mesh network, and that's great. You got a flat mesh network everywhere. You're accessing your different hosts. You don't care about what networks they're on. But you can really take it a step further if you go with the sidecar, because now, instead of having a multiplex on one host, right, you've got server A, and you run 3 different services on there, well, you access them all over server A's tailnet address, or virtual mesh network address. If you go with the sidecar route, well, now Vault Warden shows up on your network just as Vault Warden. It gets its own IP address in your virtual space, it gets its own host name, DNS, all that on there, and that means you further decoupled things. So now, you don't care where it gets moved, you don't care what host it's on, none of that matters. And Docker Compose, I mean, this also plays great in Kubernetes. That's really where a lot of the sidecar pattern came out. Folks in the home lab love it though, and I've certainly loved it. I know we've used it a lot at JB because some of them just don't have to care. This whole Docker Compose can be picked up, moved along, and the primitives given to us with containers really make it easy because they get an isolated network stack already. Yeah, so you inherit network isolation from Docker. It's only exposed to the host if you explicitly poke holes. This can kind of be annoying, but really overall is mostly a good thing. And you get application level networking. Instead of multiplexing, like I said, you just get one per app. You can get even fancier with this. Some systems exist out there to actually embed it inside of your application, but then you kind of need application changes. That works really well. Like OpenZD is a project in that space I really like. But it takes kind of going all in and really being willing to adopt it all in. So this is kind of, if you go with the sidecar approach, you get a nice middle ground where you still get, one name per app, but you don't really have to make a lot of per app changes. And really, mesh network VPNs and containers existing at the same time, we have Tailscale, we have Docker, we have Podman. It combines to make something pretty great. Okay, those are some of our primers. Now we need to move on to NixOS. It's a declarative Linux distribution. And here at Texas Linux Fest this year, we've kind of heard a lot about things like composable and atomic distributions, and NixOS definitely fits the bill here. But it's a little bit different than things like Silverblue. And that's because on top of being atomic and providing rollbacks, it allows you to define the entire state of your system in one sort of enhanced JSON file called your configuration.nix. So this is where you kind of set up all the users you want on the machine, it's where you set up the packages that you have on the machine, and it's where you configure all of the services that you want to be running. And after you've changed your configuration, checked it into Git ideally, then you just run NixOS rebuild. You can do NixOS rebuild build just to test build your machine. You can have it build that and run it in a virtual machine to automatically run tests. You can do boot as an argument, and then that just prepares things so that on your next reboot, you're automatically in that new updated version of your system. But they've even got some fancy scripts involved so it can figure out the difference between what your current configuration is and what your next configuration is, and it'll automatically diff that and figure out the right systemd units to start to bridge you between the two. And it works pretty great. When you first try, you can definitely do this on like bootc-based distributions as well, and you get the same feeling. But when you first sort of like, oh, I've got a GNOME stack going, you've got all the programs running, then you just comment that out in your config, and you enable the Plasma side, and you rebuild. And not only does your desktop environment change, but there's not a trace of GNOME left on the system. There's no GNOME programs left on your path. After you've garbage collected, there's basically nothing left on your system at all. So on top of that, like I mentioned, you do get rollback. So part of that is being reproducible and declarative, and so if everything lives in Git, Git can automatically provide you history and the capability of rollback. This is built also these days on top of Nix Flakes, which we don't need to get to a ton today, but kind of provide a lot of these primitives. But additionally, it works with systemd boot or grub, just like you're familiar if you do use bootc-based systems where you get another boot entry provided to you. So even without having to go in and rebuild and use Git to go backwards in time, it's presented to you automatically from the bootloader. So if you screw something up or the latest build doesn't quite work, you can have it automatically roll back. Okay, so just a quick little example, give you a taste of what this looks like. So let's say you want to run Nginx on your host, right? Well, Nginx on NixOS is great. Nginx is an excellent product overall, right? It's open source, super fast. The configuration file is not, I think, what anyone would call elegant, readable, pretty. You can do a lot with it, which is great, but it's one of those things where you kind of have to go let me go find some examples of someone else doing what it is exactly that I wanted. And NixOS wraps up a lot of common best practices for spitting out Nginx configurations, and it'll handle a lot of that for you. So in this case here, we've got services.nginx, and we can define some settings in there. And you can think of this a lot just like JSON, right? You've got what Nix calls attribute sets, which are just key values. So we're saying enable equals true. And that's most of it. You've also got lists of items. We don't have one here, but it's just basically lists and keys and values, except we got to have more semicolons, but it allows comments, okay? So there's some trade-offs. So if you add this into your configuration file, and then you just run sudo nixOS rebuild switch, that's it. I mean, NixOS will rebuild. It'll figure out that it needs to go download Nginx from the internet, and it'll go start the service. It'll define the systemd files. Everything gets updated. After it runs, you're done. I mean, I did this earlier today, and I think it should just still be localhost 80. Yeah, there we go, hello world. So I just stuck a hello world HTML file there. All I had to do was turn on Nginx, and that was it. Going backwards, there we go. Okay, so NixOS is also powered by the Nix language and package manager. We won't get a ton into that, but Nix itself is a functional programming language. But it's pretty lean and mean because it's mostly built to power being a build system. It's existed for a long time. I mean, I think something like 20 years at this point, but it wasn't until the last maybe 5 years that it really kind of hit a critical mass. It had enough packages, it had enough utilities, it met enough sort of like, okay, this is cool in like a math nerd functional programming way, but can I actually do anything with it? And the answer is yes, you can very much do stuff with that, including these days, there's Nix packages, which is an open source effort separate from Nix itself that has a giant cookbook of 120,000 plus different packages and 20,000 different modules. And the modules are what let you run things like Nginx or Jellyfin, and the packages, well, one great thing about Nix is it's just a package manager that you can take with you. You can run it on Ubuntu, you can run it on macOS. It's a really great complement for Brew. It's not for everything, but for dev environments specifically, so much faster, no more relinking Python stuff. It's just much better for that. And what's great is you can take it with you because you can install it just about anywhere, and everything lives under /Nix. So it doesn't mess up your existing Debian installation. It won't screw with anything else on the system. It's really easy to remove. I'm pretty much just an rmrf/Nix, and maybe it adds some stuff to your bash profile to make sure it shows up on the path or something like that. And there's a lot of really good stuff in those modules. It's got image these days, Nginx, Nextcloud, Postgres. I mean, almost everything you can find out there, it's either in Nix packages or someone else on GitHub has a flake for it. Nix also, and this is, I think, something that came around to be appreciated a little too late, it solves many of the conflicting dependency problems that we know all too well with Linux, right? Where you've got two different applications and one needs library version 5 and one needs library version 7, but on your traditional sort of Debian installation or Fedora box, well, you can generally only really have one of those library versions, so what are you going to do, right? The way Nix works is it's got a lot of static linking and playing around with ELF headers, and it basically tells it, okay, don't go look up whatever, the normal way is you say, I need library X, and then you go to the system, you kind of go dynamically look that up and load it into your program. Nix fixes all of that at build time. So once that file is spit out, that executable will only ever look for a single path based on a hash that it expects in the Nix store. And so it just won't break. You can't, if you install some other program or some other version that uses it, well, that'll have a totally different hash, and you don't screw up your system, your build environment still works. So you can do a lot of the same stuff that we now do with containerized development of production environments, but you don't have to stuff everything into container. You can still. Nix is a great way to run containers or build containers, but you can have containers are optional now. And NixOS has great mesh network support. There's a Nebula module built in, there's a Tailscale module built in, and there's a Netbird module built in, and you pretty much just enable them, and especially if you're using like the graphical auth or something, that's it, you're done. It's one line of config. Okay, so here's a bit of a challenge though. NixOS is definitely great for running home run services. It's my preferred way. After I discovered NixOS, pretty much every new service that I am trying to run, I first check to see if I can run it with NixOS. Not always, and there's some stacks where like you may want to prefer to use Docker for a variety of reasons. That's totally okay. Sometimes you just want it more decoupled. Sometimes it's not packaged in Nix, or you don't like the way that Nix is doing it. But it gives you this giant library of programs you can use, often with just 1 or 2 lines of configuration. The problem is that there's no native sidecar-like option. all of these services, they just run on the host, right? And that works great, especially for a home lab, and you just have it available on your local LAN. And we could, of course, just run a VPN on the host, right? I mentioned NixOS is pretty great for running mesh network VPN, so that's a super easy option, great way to get started. But I wanted to see if we could do better. Realistically, I kind of just thought, maybe I can copy what Docker Compose does, and we can just have this in Nix. So I've created an open source NixOS module that is an attempt to provide a similar experience that you get with Docker Compose sidecars, and maybe a bit of a soft landing for folks who are familiar with Docker Compose and are interested in NixOS. Because I've also heard from a fair number of people sort of like, they really like it, they bought into the sidecar pattern, and then we tell them, hey, NixOS is great, you might consider trying it, and then they're kind of left out in the cold. Okay, so solution, part one. Everyone loves systemd, right? Not a controversial topic at all. I definitely have come to appreciate systemd, and NixOS is one of the things, I mean, I already like systemd, but NixOS kind of gave me a new appreciation for all of the things that systemd can do, because systemd can do a ton of stuff at runtime. It's got all kinds of options for configuring dependencies between your projects, for starting things up, for handling networking to drives, right? Like, it seems like it eats more and more of our systems pretty much every year, for good or for bad. And when you pair that with a build system that has a ton of power and is basically a programming language, that means you've got a sophisticated build system that can then figure out what needs to happen and hand that off to systemd at runtime to actually make it happen. And then these days, as you can kind of see on the right here, systemd has evolved with many security and confinement options. They've basically taken a lot of the features that you have in something like Docker or Podman, and they're also available in systemd. You can do stuff like protect system or protect home, and that just, systemd won't, it'll set up some private mount namespaces, and it means it won't allow it to write to /home. More relevant for us, you can set up things like private networking, private temp devices, no new privileges. So you've got a lot of different options in terms of how confined you want things to be. And so you can have it tightly coupled to the system where it really needs a lot of access. Maybe you want to pass through a lot of devices, or you don't want to bother having to pass through the devices. You just know it needs access. Or you want to really tighten things down and have it be super restrictive. Systemd gives you the power. It has a lot of the same cgroup and namespace controls as you expect. Okay, so as just a little trial example of like something you might want to do, let's monitor our home lab, right? Turns out NixOS has modules for Grafana and Prometheus, and we can start with just like a basic config that can just run Grafana, Prometheus, and a node exporter, but without help, our basic config here will be trapped on our LAN. So that's the caveat. I'll give you a sec to look at it. Up top we have Grafana being defined. We set enable to be true, and then we can give it some settings, right? So we just kind of tell it here, listen, listen publicly, use your port. Let's turn on gzip, right? Why waste bandwidth? That's just an example of what you can set. And then you can go to search.nixos.org, and they've got all of the options available for all of the modules, so you can go find docs there. And then underneath that, you'll find Prometheus, same kind of deal, right? You can change stuff like set the scrape interval. This one's a little more complicated though, because not only are we starting like an actual Prometheus server, but in this case we're also adding a node exporter, because we actually want some metrics to come into the system. And so that's where you see we've got exporters.node there at the bottom. We're turning that on separately. You can control its port, and then you can also tell it like what stuff do you want to actually collect. So for this example, we're just kind of collecting most of the basics plus stuff from systemd, but sky's the limit on that one. And let's see it running. So if you start here, you add this to your NixOS configuration, you go sudo NixOS rebuild switch, you'll get something, this is a little bit abbreviated here, but the basic idea is it looks at your configuration, it builds your configuration, right? So that's where it actually goes and evaluates, it checks out, makes everything make sense, your code compiles essentially, then it spits out a built system, everything you need to run that system with Nix or without. And then it runs the magic activation script, which is where that switch sort of figures out what's the diff between system A and system B, what do I exactly need to stop, what do I need to start, sets up ECT, because a lot of ECT under Nix ends up being symlinks to the system configuration to make all that work. And you see at the bottom, it figures out it either needs to start, or in this case, when I was doing the sample, reload something like Grafana and Prometheus. And after the fact, if you go to systemctl status, just from this basic config, we will have Grafana running. We'll also have Prometheus running, but there's only so much room on the slide. Okay, and a little more detail about what we get here. At the top, you'll see my Tailscale dashboard. And in this case, we're just going to have the one machine present on our mesh network. And that's Node 1, that's just my ThinkPad laptop here as a demo. So it is running as like a regular host on the network. And of course, the only thing, and it's running all of our services, right? We just started with a basic config. We didn't use anything fancy. There's no sidecars yet. So if we do a modern version of Netstat with SS, you'll see that we have Prometheus listening locally on port 9090. We've got the Node Explorer on port 9000, and Grafana itself on port 3000, yeah, way at the bottom there. Okay, here's where we actually get down to business and, accomplish something. So this is the interface that exists to my new module. Well, it's not that new. I made it this summer. So first things first, it's services.mesh sidecar. You start off with enable equals true. This is just how you do it in NixOS. Next up, you've got provider. So right now we just support Tailscale and Netbird, but Nebula's in the works. It's just a little bit different, so we need some more code changes. And then you provide the auth key file. Under the hood, we use systemd credentials, so this just needs to be a path that systemd can read, and then systemd will handle copying it to a tempfs with all the right permissions so that basically only your service can really get access to it, or root. So I've got that stored somewhere secure in my system, set it up with, NixOS has various options for how you want to do secret management. You can bake stuff in, you can bring your own tools, there's lots of options, so that's out of scope, but as long as it's in the file system, you're good. One thing I'd like to improve that we don't yet is it doesn't auto-detect your outbound interface. For the most part, I'm running this on servers, so maybe not a huge deal, but you do need to tell it, how do I get to the internet? So for this example running on my ThinkPad, that's this poorly named wireless device, WLP here. We're also going to make a bridge because we're very much copying what Docker-style networking does. So we're going to have a bridge in the host network namespace. We'll get more into that. You can change the name if you want. We'll just do BR0 for today. And then the actually important part at the bottom is we define what services that we want to wrap in a Tailscale sidecar. So in this case, we just want to wrap Grafana and Prometheus. We could wrap the Node Explorer. It doesn't really make a ton of sense in this case, but you definitely can. I also just included it because we have the functionality if you want to specify a different service name. By default, we kind of just copy, so if you're running Grafana, it just uses Grafana as the host name. But if you're running several services, you probably want to change that. So you can override that by just passing in extra settings. Okay, so we've added, first things first, we add my mesh sidecar module to your system, and then you add this as your configuration for the module itself. But we might want to make some changes since we are kind of changing our architecture here. We're moving from just serving it on our home web to serving it to our home mesh network. So if we go pop over to Prometheus, one of the things that's pretty great about NixOS, and this isn't always true, and it kind of varies depending on the exact nature of the service, but you can do a lot of the configuration you might have to do at runtime, at build time in NixOS, right? So here, and it all depends on, the service has to kind of support this, but if it does, you can usually add it in NixOS. So in this case, we can add static configs to Prometheus, and we can tell it to scrape our Node Explorer. So down here under targets, you'll see static configs, and then targets, and then we have node1 dot blah, 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 and that's just the internal private domain name for my Tailscale network. And then at the end there is just an example that if you were doing this in a way that you have access to all of your networking information, you can use Nix to go look up in our services and say, oh, what's the port of that other thing I'm running? Let's just use that. And so that's one area where Docker lets you compose things, but NixOS lets you have access like that. You can see inside the configuration of other services, and that gives you a lot of opportunity to script things. So we're going to set it up to say, hey Prometheus, scrape my node over my tailnet. I want to do this all over the mesh. And don't have to change anything about the Explorer at all. And then we'll also update Grafana. So in this case, we're turning off enforced domain just to make sure it kind of doesn't get too confused. There's other setups you can do to maybe make it more production, but this was good enough. You can customize your domain down there too if you do have a more production setup. But the main thing is we're going to provision Grafana out of the box to have a data source. And that data source, well, it's going to be the Prometheus that we're running on our mesh network. So we just say name Prometheus, type Prometheus, and then pass a URL that is on our internal mesh network. Okay, and then let's see here. I've got a video. I think that's it. Yeah. So we've gone through. We've added the NixOS, the mesh sidecar module. We've updated our services to take advantage of our new architecture, and now we've got to actually, change the system. And I will do this live, but conference Wi-Fi and everything. So here's a video. Pretty switch is the same as NixOS rebuild. It just looks a little prettier. So this also gives me a chance to drink water while we wait for the system to build. It's evaluating my system, doing a lot of stuff with Git and the file system, making symlinks, side links, who knows what. Yeah, that's what happens if you haven't checked in your changes and you are doing stuff. I think newer Nix now has a better error message for that. Well, warning message. Okay, so now we've got something useful going on the screen. Stop the following units, grafana.service. There we go, yeah. Pause there. Yeah, stopped the following units, grafana.service and prometheus.service. So I figured out we're changing those. We've made some pretty incisive changes to the actual system deconfiguration, so it's definitely going to need to stop them. Then it sets up etc, does the normal NixOS rebuild stuff we saw before, and then it starts all the new units we need, including Grafana and Prometheus, and a whole bunch of other stuff, default retns, nevertheless at Grafana. And we'll get into exactly what those are, but that's the magic under the hood actually doing the work. And then rerunning down here at the bottom the SS command. Before we had three things, right? We had Grafana, we had Prometheus, and we had the node exporter. Well now, all we've got is the node exporter. After our rebuild, those other things seem to have disappeared from the host, but they are still running. And if we pop over to our Tailscale dashboard, now, instead of just node 1, which is this ThinkPad here, we also see Grafana and Prometheus. Just like we'd like, you can see there, they get individual IP addresses right on the mesh network, and you can access them just by typing, yeah. So I can just go to Grafana, it pops up, or even Prometheus, and Tailscale does the rest. Okay, so then we can pop over, like I said, pop in Prometheus into the browser. You can also, Tailscale can be configured to have a search in your etc resolve, and you can just type in one host name level. So in this case, we're just seeing in Prometheus, we did automatically configure the target that we're looking for, and it's going to scrape over here, node 1. And then, if we pop over to, oh, is that right? Yeah, great. If we pop over to Prometheus, then we'll see, or Grafana, excuse me. If we pop over to Grafana, then we do see that we also have a connection to Prometheus. So everything's working like we thought. We tried to preload things so that it would, Prometheus scrapes the metrics, Grafana talks to Prometheus, and in theory, that should all work, and what do you end up with? A dashboard of metrics! Yay! So here we can go to Grafana on our tailnet, and then it's able to talk to a Prometheus that could also be running anywhere else, any NixOS server I've got running in my fleet, which is then also able to talk over the mesh to my ThinkPad. So, I could be here, it could still be scraping it, I could go over the mesh network, talk to Grafana, Prometheus and Grafana could be back at home or in VPS somewhere, and that'll all work. Okay, so review, node exporter is running on the host. It's exposed via Tailscale on the host, kind of old school style. Prometheus and Grafana wrapped by the mesh sidecar module, isolated from the host, they no longer show up there, exposed basically only via the Tailscale interface. And this lets us escape the LAN, right? I can get access to all my stuff. I've got my home assistant set up this way at home right now, so I can go check on things while I'm here. That's great. How does it work, though? Well, under the hood, it's mostly powered by network namespaces. These are a big part of what makes Docker work, and they provide an isolated network stack for processes. So instead of having to see all of the different interfaces on your system, you can isolate them. So all they get by default is a loopback device. They don't see anything else, and you have to manually add in whatever devices you want them to be able to see. This works great with something like OpenVPN or WireGuard, because you can set things up where you start them in your main network namespace where they have outbound internet access. And then if you move that interface into a new network namespace, any processes in there, they'll only see your WireGuard interface. And so if something happens where the WireGuard interface goes down, they lose connectivity, so they never go out. They don't have an opportunity to go out your normal outbound interface. There's other ways to do it, but they're a really powerful primitive that lets you do a lot. And then we've also got a virtual bridge or switch in our host namespace. That's BR0 that we were talking about before. And this is really just like a switch, but powered by Linux. You can think of it as in various switch ports that you plug in, and then you get a layer 2 network. The main thing, though, with the network namespace is we do one per service. So Grafana gets one, Prometheus gets one, anything that we want to wrap with this module gets one, which is basically the same thing you get if you do the Docker sidecar style, right? You just have a separate compose stack for each thing you're doing. And then, well, this is great for isolation, but we do want things to be able to talk to each other because we do need packets to ultimately be able to reach the internet if they're going to be accessible to the rest of our mesh network. So how do you do that? If you're using network namespaces, then you got to use virtual Ethernet pairs or VETH devices. And these are really just like a virtual Ethernet cable, right? You get to plug one into one side, you plug one into another. Here, both of the sides are just network namespaces, right? So you put one in the host, and then you put one in your new network namespace to isolate a service, and then packets can flow across that. So in our case, we can put them into the bridge. And then that means each network namespace has access to the bridge, and if we do outbound NAT from the bridge to our outbound interface, they get internet. And so that's a lot of what Docker Compose does by default with Docker Network. You can do more complicated things, but that's what we do too. So we add all of the host side. So the virtual Ethernet device has a host side part and a per network namespace part. We take all of the host side pairs, we add it to the bridge, we get our NAT going, basic firewall rules, that works. And then on the other side, they not only have their loopback interface, but they get a new interface in their network namespace. And it's the only thing they have access to. And of course, under the hood, there is a whole lot of systemd, because there has to be. Here's just a very basic little network diagram, right? If we're on our host OS, we can go to our browser. That can use Tailscale to get to the network over the mesh. That lets us get to our Grafana namespace. In our Grafana namespace, we have the Grafana sidecar Tailscale running, and we also have the actual Grafana service itself. And then, as you can see, we have one connection into that namespace from the mesh right here, and then the other one, how it actually talks outbound and is even able to establish a connection, is our virtual Ethernet pair that talks to this whole namespace and connects to our bridge. This is a bit more of like a full model if you include not just Grafana, but something like Prometheus too. So here we can see that the Grafana service can talk to our Grafana sidecar Tailscale VPN, and then over the mesh, it can go talk to the Tailscale running with Prometheus, which gives it access to Prometheus. Same deal, this gives it access to our Node Explorer over the mesh network, and they can all feed together over the mesh. Just a bit of details here at the top. If we go take a look at what the systemd file for the service file for Grafana looks like. The main thing that this module ends up adding is here at the top under the unit part, which is binds to, and that tells it we're linked, so that systemd understands that like if we go down, it should go down, and vice versa, and joins namespace of. That's really the magic bit that says, hey, I have some other service that's running. If it has private namespaces, whether that be like private mounts or a private temp directory or private networking, I want those same namespaces. And that's what lets us combine stuff like Docker Compose does, like when you get a virtual Compose network that has all of your containers in it. And then this is just to take a peek. If you were to go look at like, well, what does this look like on the command line if I'm running IP adder? So this is the mess that you see on my laptop in the host namespace, so sorry about that. So we've got normal loopback, and then this was at home on a Thunderbolt device. These are just some extra Ethernet devices. This is the wireless outbound, so start paying attention there. Tailscale 0, that's the host level, right? That's what's letting us have our Node Explorer, just normal Tailscale running on the laptop. BR0, that's our bridge. And then we have two new things. We have Grafana and Prometheus. And those are the host side ends of our per namespace virtual Ethernet devices. So those are the links inside. And then if you pop yourself into one of those network namespaces, here's what you see. You can see you can do that with sudo IP netms exec, which is a super handy command to pop you in. You can also use things like ns enter to do this as well, but this is a little bit easier. Inside the Grafana network namespace, run IP adder. So it has its own loopback as well, and then eth0, that's just what I named the per service side of each of the virtual Ethernet devices. So inside each of their little view, they each get an eth0, which is kind of what Docker often does too. So it gets this little device here on its own internal network, and because it is running Tailscale inside the same network namespace, it gets its Tailscale mesh IP. Okay, so this was all going pretty well. Let's see here. Yeah, great. This was all going well, right? I was like, hey, proof of concept. I was able to wrap a couple simple services in my home lab. I'm going to put this out into the world, open source. Probably no one else wants it, but since I kind of wrote it because I thought people are asking, can this be done on NixOS? And I wanted to say, like, yeah, it can be done. We can. But then, someone else actually tried to use it. So props to TK17, who is a listener to the podcast, who actually went to try it out, but they tried out paperless, or paperless NGX, which is a NixOS service. It's a great way to run it. In my scenario, the paperless module already defined the multiple services that were joining each other in their namespace. So there was a conflict during evaluation. And TK1 was even good enough to open some PRs to try to address things. It worked out that ultimately I wanted to go a different way to address those problems, but TK1 brought up paperless, which turned out to be a great test case for kind of ironing out the real world use of the module. So if you're not familiar, paperless NGX is a document management system. Basically it's a archiving system that sets up things like OCR and tags and search. You can integrate AI these days into it, and so you can scan things from your phone or send documents from your email or your computer, and you have one place to store and view and search all of them. So super handy utility. User wanted to use Mesh Sidecar, but paperless is kind of a complicated app. It's a modern Python app, and so of course it kind of has multiple services. It has a web front end. It has a task queue using Redis, and then it has a consumer that reads from the queue and actually does a lot of the background stuff, like maybe OCR in your PDF. And then it also runs Redis, and it has Postgres as well. You need to store all the data here. And because NixOS is actually pretty good at this these days, they try to use as many of the system dehardening functionalities that do exist as they can without breaking things. So it kind of already uses some of the stuff I'm using, which is why things were breaking, because we were telling systemd to do multiple different sort of incompatible things with how to confine these services. Because we definitely manipulate a lot of stuff about the service, particularly those two that we saw earlier. But paperless already had private network, is true, not with all of its services, but with some, but a different private network, unfortunately. And then it also uses private temp, which gives its own private /temp and /var/temp. And it uses this in particular for some of its consumption. Other services can write temporary files, like some of your uploaded PDFs go in there before the consumer ultimately reads it and puts it into final storage. And not only do they have multiple services that are running, but they're also quite interdependent, of course. So systemd handles that. The task queue service actually ends up being the base. So the way they set it up in the module is the task queue service sort of starts first and is the base namespace that all of the other services then join. They all share the same temp. Some have network isolation, like the queue doesn't need network outside of how it consumes, but others do not. And the early version of Mesh Sidecar did not play nicely. But it turns out that really the way to solve this was don't fight the isolation, see if you can just enhance it and work with it. So ultimately now we end up adding temp isolation to most of our services by default now. That ended up working out to be A, kind of more secure, and then B, it played nicely with a lot of modules in NixOS. So we're going to offer ways to poke that hole out if you do need to access /temp on the actual host system. But for now, we add that in. And this allows Mesh Sidecar to play a little nicer. What does that look like, though? The fix, so we add in our paperless service. One of the things to know is because there are multiple systemd services for paperless, that's what goes as the key in this little map here. So paperless web is the thing that actually presents you the web interface to interact with paperless. So that's the thing that we want to wrap with the Mesh Sidecar module. So we wrap the paperless module, the paperless web service, excuse me, and then this is the case where, okay, I don't really want to see paperless web, in my internal network, we could probably do better, and so that's where mesh name comes in, and I'm just going to call it paperless. But that was not, unfortunately, that's not quite enough. That's where the user started, and that did not work. But now we have what I'm calling known service overrides. I know it's a mouthful, so better names, totally welcome. And then ideally, right now there's only paperless, but in the future, we're going to have more options for different services that need these kinds of overrides. So the idea being that we could upstream some common fixes to these kinds of stuff to play nice for the ones that already have isolation that need a little more work, and then if that's supporting for the thing you want, you just turn on the override. And then also if you want to copy the override and change it or tweak it to make it your own, then we're not forcing this stuff on you without you kind of having an idea of what's going on under the hood. And speaking of under the hood, you can take a glance here just to see, basically you get stuff like if statements, and I can check to see well, did you want to use paperless? I'm not going to make all these changes to the system if you didn't actually use paperless. So I can kind of see did you enable the module? Did you enable paperless itself? Did you enable the override? And did you actually even bother to turn paperless on in the system at all? Because if you didn't do that, then none of this matters. And here we kind of just do a little more of the same kind of configuration where we say, okay, we need a private network, right? This guy didn't have it before, but we need it, so we can use something called make force, which is a way to handle overrides in NixOS. So just say yeah, I know the other guy said that he wanted it this way, but I'm the last straw, so I get to say. And we set up some stuff to play nice with resolve conf, and then we kind of add on the rest of the stuff we need. We need to add in joins namespace of. At the end of the day, we're basically able to say, hey, paperless task queue, I know you needed your own network namespace, but you're just going to join ours, buddy. And if we do that, then the rest of the stuff that joins it kind of gets in for free. And as long as we make the right changes to all the modules or all the different parts of the core service, it works. It works just fine. Actually, I can show. Yeah, right here. I don't know if it'll refresh, but I can go to paperless right here in the web browser. It uses a silly port, but put the great Nginx module from NixOS in front of that, and it doesn't break. You can upload documents. I had the user do some testing. I did some testing. So at the end of the day, we now have a real-world services. They are complex. I had some lessons learned there. You can't really assume a clean state. You do have to compose with existing isolation. As usual, community feedback makes, most things better. And now, Mesh Sidecar is able to handle multi-service apps gracefully. That's the only one, so we are going to add some more. I have a couple in mind that I want to test from Nix packages, but, have to finish the talk first. So what's next? Well, let's call it alpha for now. I do hope that we have enough of the interface figured out not to have crazy break-in changes, but no promises, but I'll do my best. I would also like to add more VPNs, right? So I've tested Tailscale and NetBug because I end up using both of those. And now we're doing more Nebula over at Jupiter Broadcasting, so that's next on the list. But, there's a bunch of other options these days, so if there are people who want other mesh network VPNs, totally cool with that, as long as they can play nicely with sort of Docker-style sidecar private networking model, then it should work. I'm also interested, I mentioned the bit about, you can have a WireGuard interface as the only thing in there, and it doesn't have a chance to use the main outbound interface. Well, we could do that too. It would take a couple more network namespaces sort of being created and thrown away during the process, because right now they basically get access to the mesh, and they get access to your normal outbound interface. You can add firewall on the host to fix that, or there's a lot of options. But one thing we could do is just say, hey buddy, you got to get out to the internet through the mesh, or you're not getting out at all. And just in the most recent systemd release, there's been more features for isolation and namespacing, plus it looks like some knobs to say we have joins namespace of, but that's kind of all or nothing. They're giving some knobs to pick or choose which namespaces for another service you do want to join. So that might be useful for this as well. And then it's open source, so whatever you want. If you use it, you want to contribute, you want to make it better, please do. And that's it. This is Mesh Network Sidecars for NixOS services. If If you took one thing away, it should be embrace the flat mesh network with per application network entities powered by mesh networks, network namespaces, systemd, and Nix. And you can find it at github.com/noblepayne/mesh sidecar. And thank you for coming, and thank you to Texas Linux Fest. That's it. And then questions, I guess. And if you don't have them, great. Come find me afterwards, too. Oh, question? Yes. I've only done a limited amount of testing on that, but yes. As long as you do, but you need to add in some of your own overrides right now. What I'd like to do is add in a couple extra features to make that a little bit easier. But as long as you've got all the right, you can connect to your private server and you've got the right key set up already, then yeah, as long as it can do all the off-key stuff. But I think it does, right? Yeah. Yes, in the back. What was that? What was the other one? Not at the moment, but if you want to open an issue or a discussion, I won't say no on stage, that's for sure. Yes? Is there any problems on Nix with setting it up with the mesh setup? No, yeah, it works great on Nix, and then what we're doing at the moment is letting on top of the namespacing we do, you saw a little bit there, we bind that in per service etc resolves, and then Tailscale can just handle that, sees it, and yeah, it all just pretty much works. And so they can talk to through Magic DNS and all the normal stuff in each service. All right, thank you all very much. See you next year.